Let's talk about conservation of linear momentum. The conservation of linear momentum theorem states that in an isolated system, the total linear momentum will be conserved both in magnitude and in direction. We use this formula to show conservation of linear momentum. This symbol over here stands for sum. So if you were to read this, it would go sum of momentum initially is equal to sum of momentum finally. To understand why momentum is conserved, let's look at our impulse formula. Our impulse formula goes as follows. F net times change in time is equal to change in momentum. We learned from Newton's third law that when two objects exert forces on each other, those forces that they exert on each other will be equal in magnitude. So imagine two objects are colliding with each other. The net force will be the same. The time during which they come into contact with each other would of course be the same also, because how can two things come into contact with each other and then one be in contact with the other for less time? That doesn't make sense. So the time during which they come into contact with each other, that will also be the same. So now think about it. If these two are the same and they always stay the same no matter what, then wouldn't this also be the same, this value over here? And that's why we say that the change in momentum will be the same for both objects. Let me give you a scenario to work with. Let's say, for example, there is a block which has a momentum of 8 kilograms times meters per second. And then you have another block with a momentum of minus 4 kilograms per meters per second. And now these two are going to collide with each other. So whatever this block gains in momentum, this block will lose in momentum. And whatever this block gains in momentum, did I say that already? Whatever this block loses in momentum, this block will gain in momentum. So it's always what you take away here, you have to add somewhere else. And what you add here, you have to take away somewhere else. Let's say after this collision, this block now has 2 kilograms times meters per second in momentum, and now this other block also has 2 kilograms times meters per second, and they move off together. What has happened here? What is the change in momentum? Here we've lost 6, and here to get from minus 4 to 2, we have added 6. Does the momentum remain the same? Let's see. If you add 8 kilograms per meters per second and minus 4, you should get an answer of 4. And down here, if you add 2 and you add 2, you should also get an answer of 4. That's what we mean when we say that momentum is conserved. By the way, this only happens for isolated systems. This is what we would call an isolated system, where the only force acting on these objects are the force that they exert on each other. What would not be an isolated system was, say for example, a box were to collide with a wall. This is not an isolated system because the wall has external forces that connect it to the ground. These forces hold the wall in place, and that is why the wall cannot move when an object with momentum bumps into it. So this is not an isolated system because they are external forces, but this is an isolated system. So you could use this formula which goes sum of momentum initially is equal to sum of momentum finally. You will find questions where we practice using this formula in later videos in this section. So look out for those practice videos which are further down in this playlist.